Hi, I'm Lee Teschler, Executive Editor at Design World Magazine.
And I'm Michelle DeFrangia, Assistant Editor at Design World Magazine. Today we have in front of us the pieces parts of a pretty cool toy called the BB-8 that was inspired by the recently released movie Star Wars: The Force Awakens.
Right, Michelle. The BB-8 is made by a company called Sphero, and its design is actually pretty close to two other toys they make called the Sphero and Sphero 2. The big difference is a movable headpiece that floats on top of the BB-8 as it rolls along. The toy's mechanics sit inside a relatively thick polycarbonate sphere, which we hacked into. The main structure is a plastic frame that holds the circuit board, two motors and two lithium batteries, a charging coil, and a plastic mast that sits on the frame. The plastic mast holds a couple of magnets that attract the BB-8's head and let it stay in place as the toy rolls. The toy is able to roll on command thanks to a pair of small DC brush motors in the base of the plastic frame. They just sit above the wireless charging coil that lets the BB-8 recharge when it sits in its charging base. The motors are from a Chinese company called Standard Motor. They're nothing special. They're what's dubbed 130 series motors, which are a type that's widely used in toys. The particular motors used in the BB-8 have carbon brushes and a somewhat stronger magnet than what some kinds of 130 motors contain, probably so the toy has enough torque to rotate itself with the additional load of the head rolling around. And the gear ratio for the two gears you see between the motor shaft and the drive wheel is about 4.3 to 1.
So Lee, I need a smartphone app to control this thing. How does the toy know how far and fast to move?
The secret to that is the servo-controlled motors. You can tell servo controls happening from the encoder wheels you can see mounted on the motor shafts. The wheels apparently form encoders with alternating magnetic areas that are picked up by a couple of Hall effect sensors visible on the small circuit board on the motor shaft. The feedback from the Hall sensors probably forms some kind of velocity or position loop. There's no way to know for sure whether it's really a velocity or position feedback that this thing uses, but velocity readings would probably do the trick for the kind of movement the robot executes. With velocity feedback, the processor tells the motors to spin at a certain speed in a given direction. The encoders feed back what the true motor speed is. Then the difference between the commanded speed and the true speed is an error signal that drives the motor. In the same vein, the encoder feedback could serve as a measure of the BB-8's position simply by letting the processor count pulses coming from the Hall sensors.
Okay, but how does it know when it bumps into something?
The feedback from the encoders can tell you that as well. Say the BB-8 hits a wall while it's in patrol mode, and patrol mode is where the robot wanders around on its own. When the BB-8 bumps in against a wall, the motors don't have enough torque to spin the wheels, though the motor isn't moving. In that case, the processor will issue a velocity command, but the encoder signals or lack of them will show that the robot isn't moving. The processor will use that information to reverse at least one of the motors and try to back away from the obstacle. It'll use the encoder feedback in a similar way to find a path away from the obstacle.
So there's supposed to be a gyroscope sensor on this thing. Does that enter into getting away from the obstacle?
That's not its primary role, but it may get involved. The gyro is on the main circuit board, which plugs into the plastic frame via 4 electrical connectors. The circuit board sits on top of the two 3.7 volt, 350 milliamp hour lithium batteries, which come from a Chinese company called Full River. There's a thin plastic cover that sits over the batteries and separates them from the circuit board. The board itself has components on two sides, but it's tough to tell whether it has more than 2 layers. The 2 LEDs sit on the top side, as do the 8 ICs, including the Gyro Sensor. There are 8 ICs on the board. 5 of them have identifying markings, but unfortunately the gyro does not. So we're guessing as to who makes it and what kind it is. But the markings on one particular 16-pin SOIC resemble some of those that you find on sensors made by analog devices. So it's possible the sensor is some kind of a variant on an analog devices chip. In any event, it produces an output in response to some kind of acceleration or rotation of the circuit board on which it sits.
Now on the smartphone app that you use to run the BB-8, there's a mode which reads out acceleration and the path of the robot. So what you are seeing there is the output of the accelerometer then?
Exactly.
Something that surprised me was that you could use the smartphone app to read the temperature inside the robot. Does that have anything to do with the accelerometer?
Well, oddly enough, it might. You can see the temperature probe on the board right here. And it does seem a little weird to get a temperature reading out of this thing. After all, what do you care what the temperature of the robot is? But there may be a reasonable explanation for that temperature sensor. It's common practice to temperature calibrate gyroscopes to improve their overall accuracy. And it may be that the real reason the temperature sensor is in there is to keep the gyroscope output from drifting with temperature. But the designers of the BB-8 may have figured that since they had to put a temperature probe on the thing anyway, why not also read out its output on the phone app?
That makes sense. So what else is on the BB-8 circuit board?
Well, there are 5 chips that we can identify from their markings. The main processor is an ARM Cortex-M4 from STMicro. That's a 72 megahertz 32-bit device. There's also a 512 kilobit serial EEPROM that's also from STMicro. A Hutai battery charger chip handles the wireless recharging of the 2 lithium-ion batteries. And there's a Bluetooth Smart chip from CSR. Bluetooth Smart is a low-power version of Bluetooth that a lot of battery-powered devices are starting to go to. And there's a chip holding dual op-amps made by UTC. That leaves 2 other chips on the board unidentified, but we can make some good guesses about what their functions might be. There are 2 LEDs on the board that give off either blue light or red light depending on what the BB-8 is doing. So it's likely that one of the mystery chips has a role in generating the constant current source you need to drive the LEDs. To figure out the likely role of the last mystery chip, it helps to know that the processor in this thing from STMicro doesn't contain any kind of special circuits for driving motors or for handling servo loops. That leads us to conclude that the last mystery chip probably has something to do with driving the 2 motors, closing the feedback loop around the magnetic encoders, and reversing the motors if necessary to get the BB-8 away from an obstacle.
So now, Lee, I have to ask you, did you use the Force to help you analyze the BB-8?
For this project, I found that a table saw and a magnifying glass came in handier than the Force.
Well, may the Force be with you, and thanks for watching our video. You can see more teardown videos like this one at designworldonline.com.